put two identical cuts of beef side by side. The meat itself is indistinguishable, but look closely at the edges. One is framed in creamy white fat. The other is trimmed in a distinct, heavy yellow. For decades, buyers standing at the meat counter have made an immediate judgment. They see that yellow tint and assume the meat is old, rancid, or starting to spoil. Conversely, a newer claim suggests that deep yellow fat is the hallmark of quality, an automatic proof of a 100% natural, grass-fed, and healthier animal. Both conclusions are wrong. Fat color isn't a food safety meter, and it doesn't function as a complete nutritional label. To understand the color, we have to look past the label. These carcasses contain a physical record of the animal's biology and a lifetime of nutritional data. This color is a phenotype, a visible manifestation of the interaction between an animal's environment and its genetics. The pigment responsible for this color is beta-carotene, part of a family of compounds called carotenoids. Cattle ingest these pigments directly from their environment while grazing on fresh, plant-based forage. This raises a question of biology. How does a diet consisting of green plants produce concentrated yellow pigment in the tissue? It comes down to visual dominance. Green plants are rich in beta-carotene, but during active growth, the chlorophyll is so abundant it completely masks the yellow and orange pigments underneath. This is the same process that changes the color of autumn leaves. As chlorophyll production stops, the underlying yellows and oranges are finally revealed. A pasture functions as a vast reservoir of hidden pigments, waiting to be ingested and stored. Once consumed, these fat-soluble carotenoids are absorbed into the animal system. Inside the body, the pigments enter a metabolic sorting process. The animal converts some beta-carotene into vitamin A to support vision and immune function, but a significant portion remains intact. These surviving yellow pigments are transported through the bloodstream and eventually deposited directly within the animal's pale adipose tissue. The fat effectively captures the history of the animal's diet, retaining molecules from the environment itself. If carotenoids are universal in grass, you'd expect every pasture-raised animal to look identical. They don't. Physical traits are determined by a specific biological formula. Phenotype equals genetics multiplied by environment. Different breeds have different metabolic capacities. Some animals are genetically coded to retain these pigments more efficiently. Age adds another layer to the environment. Older cattle have more time to accumulate these pigments, resulting in a deeper yellow over years of exposure. The quality of the forage matters. Unlike fresh grass, dried hay loses carotenoids through oxidation, meaning a forage-based diet isn't always a high-pigment diet. When cattle move to a grain-based finishing diet, pigment intake drops. As the animal deposits new, whiter fat, the existing yellow color is slowly diluted. Two animals standing in the same field can yield different results because they are unique biological systems with distinct histories. This distinction separates the biology from the safety of the meat. Carotenoid accumulation is a natural byproduct of a healthy grazing animal. Microbial spoilage is a post-processing failure, often caused by poor storage. They're separate events. This natural yellow pigmentation is simply evidence of a complex biological life on pasture, not a failure of hygiene or a sign of meat spoilage. At the butcher case, choices are often made in seconds based on visual cues alone, but color alone is an incomplete measure. White fat does not prove a grain-fed diet, and yellow fat does not prove an animal was exclusively grass-fed. Many markets pay a premium for bright white fat, driven by established culinary preferences and cultural expectations. These market values aren't grounded in biology. A higher price for white fat doesn't make it objectively healthier or superior to a yellow fat carcass. To accurately read the color of beef, you meet the context of breed, age, and feeding duration. The next time you see a yellow fat steak, look past the visual preference and consider the biological story that produced it.